Just like we did in lenses and in curved mirrors, that's what we want to treat in this particular class too. So for this class, we'll be looking at lens formula. The formula is just like the formula for mirror too. So the formulas are not different, they are the same formulas, but we are going to see how to apply them to solve problems in lenses. So welcome to our class for today. This is Normal Science just online, and I hope you've gotten your writing materials ready so that we can go straight to the class. But before then, if you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? So you can reach us through the WhatsApp number that's showing on your screen. If you have any challenge, place it there. Give us a call. We are ready to help you, right? So please, if you call and we don't answer, just type your question on the WhatsApp chat. Somebody will be there to respond to your question and to your request. Okay, so thanks a lot. Let's go straight to our class for today. Okay, so as I said, we are looking at the lens formula and magnification of a lens. So if you look at this equation, you know that these are just exactly the equations we used when we are talking about curved mirrors. So the equations remains the same, nothing has changed. Magnification is image height all over object height equals to image distance over object distance, or image size all over object size. Okay, then another equation that you need to know is the power of a lens. The power of a lens is equals to the reciprocal of the principal of the focal length, and the unit is diopters. The unit is diopters. Okay, so for lenses, F is positive for a convergent lens, okay, and F is negative for a divergent lens or concave lens. Real objects are and images are positive and visual images are negative, just for your notice. Alright, so this is the lens formula, and there's nothing much to say on this than to go straight and apply it to solve some problems. So right now we're going to apply it to solve some problem on lenses. Okay, so let's go straight. So this is a sample question I want us to look at. This one says that an object is placed 36 centimeters from a converging lens of focal length 24 centimeters. So if a real image which is 4 centimeters high is formed, calculate the height of the object. Okay, so this is a wire question, and here you are giving we are giving in this particular question u is given to us to be 36 centimeters. We are also giving f is given to us to be 24 centimeters, and they give us image that I will represent with capital H. Please pardon me, but I'm representing that one with image height to be 4 centimeters. I'm representing with capital H, the object height with small h. So this is unknown, and that's what we're looking for. But before we can find the height of the object, we must first of all find the image distance. Okay, so we must first of all find the image distance. So from the lens formula equals to 1 over u plus 1 over v, we can make the image distance the subject. So we have 1 over v equals to 1 over f minus 1 over u. Right, so substitute your values into this equation. You have 1 over 24, which is the focal length, minus 1 over 36, which is the image distance, object distance, I mean. So find the SM of this 24 and 36. You will have 72. 24 into 72 is equals to 3, and 36 to 72 is equals to 2. By the time you subtract that, you have 1 all over 72. So from here now, I've gotten that 1 over v is equals to 1 over 72. So v will be equals to what? 72 centimeters. So we can see that the application of length formula is just like the mirror formula. Then for you to get the magnification of this, to find the height of the object, we know that magnification is equals to image height, which are represented by capital H, all over object height, which are represented by small h, is equals to image distance all over object distance. So if you substitute to this equation, you are going to have that h, which is the height of the image, is 4 all over object height, which is unknown, is equals to image distance, which is 72, sorry about that, all over object distance, which is equals to 36. These two can actually cancel out, so that you have, this will be 2 over 1. Okay, so now you have that h, you have that 4 over h is equals to 2 over 1. Right, so if you work this out, you are going to have that h is equals to 4 divided by 2, which is equals to 2 centimeters, which is equals to 2 centimeters. So which means that the image height, the object height, is equals to 2 centimeters. Is that okay? So look at the way I went through the problem and then solve for the object height. So if you look at this question, you find out that it's just essentially like when we discussed curved mirrors. Okay, so let's do another one. So this is another question. Say an object 5 cm is placed at a distance of 20 cm from a convex lens of focal length 8 cm. Calculate the position, size and nature of image formed. So in this particular question, we are given that object height, which I represent with a small height, small h, is 5 centimeters. We are given a object distance u is given to us to be 12 centimeters. We are also given f, which is focal length. They are giving it to us to be 8 centimeters. Okay, so these are what we are given, and then we are asked to find the position of the image, which is the image distance. We have to find v, which we don't know, and then we also have to find the type of image. Then we also have to find the h, which is the height of the image. So these are what we are asked to find. Not this one we don't know. Okay, so for us to find the image distance, we'll use the length formula. 1 over f is equals to 1 over u plus 1 over v. So 1 over v is equals to 1 over f minus 1 over u. So substituting into this equation, you are going to have 1 over 8 minus 1 over 12. So the LCM of 8 and 12 is what? The LCM of 8 and 12 is what? 24. 8 divided 24 is 3, and 12 divided 24 is 2. So that gives us 1 over 24. Alright, so from here, which is 1 all over v is equals to 1 all over 24, and v is equals to 24 centimeters. Now, because the image is positive, the nature of the image is that the image is a real image. The image is real. Okay, the image is real. That is the nature of the image. So we have gotten the position of the image, we have gotten the nature. Remain the height of the image. So we say that height of image height all over object height is equals to image distance all over object distance. So if you substitute into this one, you're going to have the image height, which is what you don't know, all over the object height, which is 5, is equals to the image distance, which is 24, all over object distance, which is 12 centimeters. So if you these two cancels out, you have 2 all over 1. So you can write this equation to be capital H, capital is image height is equals to all over 5 is equals to 2 all over 1. So which means that H, which is image height, is equals to 5 multiplied by 2. So that gives us 10 centimeters. Okay, so this is also how to apply this length formula to solve other type of problem, right? I hope you are following. So let's go to another one. So this is another question. Say that a lens of focal length 50 cm forms an upright image 4 times the size of an object. Calculate the distance of the image from the lens. So in this particular question, you are given focal length is given to us to be what? 15 centimeters. Any problem you want to solve in physics, you must bring out what you are given so that you know what you are trying to solve. Then you are also given that the magnification is given to you to be what? 4 times. It forms an image. We know that magnification is equals to V all over U. So the magnification that is given to you now is 4. The magnification is 4. So 4 equals to V over U, and U is equals to V over 4, or you can also write that V is equals to 4U, as the case may be. So you can have these two variation of this equation from here, because here you are asked to find the distance of the image from the lens. So what you are looking for in this particular question is V. You are looking for V. Now from the lens formula, we have that 1 over F is equals to 1 over U plus 1 over V. So for this particular formula, and looking at what we have here, which of this one will you substitute? Are you going to substitute U is equals to V over 4? Because here you are looking, in this particular question, you are looking for V, which is the image distance. So what you will substitute should have V on it and not U. Because you are not looking for object distance, you are looking for image distance. So which means you are going to substitute for U. So U is V over 4. So that is substitution that you should make. Okay. So for this now, you are going to have that. So when you substitute into this equation, you are going to have that 1 over F is equals to 1 all over V over 4, which is our U, plus 1 over V. So work this part of the equation out. Well, this will give us 4 over V plus 1 over V. Do your simple mathematics. This will invert because this is the reciprocal of V over 4. The reciprocal of 1 all over 1 over 2 is equals to 2 over 1. Remember, so that if you are forgetting or you are confused, you can use a simple one too. If you can remember this, you will know that 1 all over 1 over 2 is equal to 2 over 1. Or you can say 1 all over 1 over 2 is 0.5. 1 all over 0.5 is equals to 2. Is it not? So and that is exactly what we have here. So this is what this equation is telling us. So now find the LCM of this. LCM is V. V into V is 1. So this will give us 4. V into V is 1 plus 1. So this gives us 5 over V. Remember we are giving the focal length to be 1 over 15. So substitute that into here. So you have 1 all over 15 equals to 5 over V. So your V now will be equals to what? 15 multiplied by 5. By the time you solve that out, you are going to have that V is equals to 75 centimeters. So this is the image distance, 75 centimeters. Okay, so I hope this is quite simple. That's why I made this simple analogy so that you can remember, because sometimes when you see this one you get confused. There's nothing for you to, if you are getting confused in this, just remember this simple analogy and that makes it easy for you. All right? Okay. Another question, another problem I will need to solve. By what factor will the size of an object placed 10 centimeters from a convex lens be increased if the image is seen on a screen placed 25 centimeters from the lens? So from this question, right, we have that object distance is equals to 10 centimeters. Image distance is equals to 25 centimeters. So they're asking you to find the magnification of the image. Magnification is equals to image distance over object distance, which is equals to 25 over 10. So this gives us 2.5. That is the magnification you are looking for, 2.5. Okay, so that gives you 2.5, and that is all. Nothing much to write here. It's a jam question. So this is just how to go through this kind of problem. So guys, thank you. This is your test page. This is your test page, so I will encourage you solve all these problems. Check your textbook too and solve some more problems. That's okay. I have to do some research to root out all these questions from different past question papers. So try to go through them, then also look for your own answer solve too. If you have any challenge, reach out to us. We are there to help you. Okay, so thanks a lot for your time. But before I go, please, if you have not subscribed to our channel, please, what are you waiting for? Subscribe to the channel, give us a like, give us a thumbs up so that you can encourage us. So it takes a whole lot doing research and all that to put all these things together. So you just give us a like and thumbs up and then subscribe, click on notification bell. Right? So thank you so much for your time. Share this video, invite your friends to reach us through the WhatsApp number that is showing right on your screen. Okay, we are there to help you. Thanks so much, and we hope to see you in our next class. Thanks.